Myself Ritika, I am going to deliver my lecture on the topic chemical equilibrium. Before studying this topic, we should know the reason behind studying it. So in chemistry, when we talk about any chemical reaction, the first question that comes to our mind is that whether this reaction will happen or not. Or I can say that whether the reaction will be feasible or not. And if it is feasible, then up to what extent it will be. So if we talk about the feasibility of the reaction, then the thermodynamics comes into play. But when we talk about the extent to which reaction is happening, then the chemical equilibrium will come into play. So now we'll understand what chemical equilibrium is. And to understand it, let us take an example. In this example, I am taking the two reactants A and B respectively, and I am assuming the reaction to be reversible as indicated by the arrow. So the equilibrium will be established in system when the reactants combine to give the product and product combine to give the reactant at the same rate, or we can say that rate of the forward reaction is equal to rate of the backward reaction. Okay, so now I must tell you that the equilibrium is a dynamic process. What do I mean by dynamic? As the name indicates that it is not static process. Although it seems to be static because the net change occurring is zero, but it is not static process. That means the reactants are getting converted into product and the product is getting converted into the reactant, but their concentration is remaining the same. That's why it seems to be static, but it is not static, it is a dynamic process. Then on the basis of the extent to which reaction will occur, I am classifying this into three types. The first type is if the extent of the reaction will be 100%, nearly 100%, then what will happen? We will understand this with the help of graph. So when we plot graph between concentration and time, and we take the extent of the reaction to be nearly 100%. What we mean by nearly 100% is that the majority of the reactant molecules will convert into the product molecules. I am not saying that whole of the reactant will be converted into product. Major amount of the reactant. So the concentration of the reactant will decrease and accordingly the concentration of the product will increase, and there is one concentration at which they have the same concentration. There is one point at which the reactant and product will have same concentration. So it means that concentration of the product and reactant is constant, and that state is known as equilibrium state. And the next case is if the extent of the reaction is nearly equal to 0. That means that negligible amount of reactant is getting converted into product and negligible amount of product formation is happening. So it means here in this graph, this is the equilibrium state. Okay, and when we discuss the third case, in the third case, we discuss that if the extent of the reaction is less than 100 but greater than 0, then the graph will be like this. Here we can see that no doubt the reactant concentration is decreasing and the product concentration is increasing, but not in pronounced amount. They are varying in lesser amounts. So here the equilibrium state is this. Okay. So these are the broadly classified types of the extent to which reaction is occurring. Now, as we know that the extent of the reaction will be studied by the equilibrium, but we must know that how we'll get to know the extent of the reaction. Obviously, we can use the graph. From the graph, we can come to know that what is the concentration of the reactant that is being converted and what is the concentration of the product that is being formed. But there should be some relationship between them to understand them more, to understand them more. Yes, okay. So for this, the relationship that relates the concentration of the reactant and product with the rate of the reaction is law of mass action. So let us see what that law is. To understand that law, I am going back to the previous example. Basically, this law states that instantaneous rate of the reaction will be directly proportional. Let me write, instantaneous rate of the reaction will be directly proportional to the concentration of the reactants raised to the power that will be equal to their stoichiometric coefficient. And this is the expression I have written for the forward reaction. And if I am talking about the backward reaction, then expression will be like this. So I hope this lecture helped you to understand the basic of the equilibrium. Thank you.